Hopefully you guys have tried this out on your own as always. This is sort of a rough estimation. You can think of it as a somewhat practical exercise in a range of housing prices for Hawaii. It's probably on the low side, but that's okay. You can tweak it accordingly. So when you get the average price, let's just add these all up, divide by 1, 2, 3, 4, 5, right? And you should get this number. The median, remember, is different. It's the middle number, what basically has as many above as below. If there's an odd number, you just pick the middle number. If there's an even number, you take the two in the middle and you add those two together, divide in half, and that's your median. In this case, it's an odd number, so 700,000 is the median. Um, And if you graph this, it looks something like a bell curve. There's 10%, 40, 40, 9%, and 1%. Bell-ish, remember. Now, you have to draw a diagram. When you draw that diagram and you list it, the expected value then becomes the following, right? So it's the probability. Remember, expected value is probability times the utility for each component part. So it'll be 200,000 times the percentage, 10%, which is 20,000. 400,000 times 40%, and so on and so forth. When you do the calculation, you get this number. Why am I having you do that? Well, very often when you read about average prices in wherever, let's say Hawaii, right? For whatever it might be, income, it might be housing, any number of things. They don't very often talk about what that average means. The notion of average can be tricky. Are they talking about the average in terms of what we mean here, the mean, meaning you add them up and you divide by that number? Are they talking about the median, as many above as below? As discussed in the previous lecture, all of these can be misleading. The only real true notion of average, or I should say the best notion of average, which is because what you want when you talk about average is what's really the average price, what's in the middle, not as many above as below. If you're talking about as many above as below, there's a number of ways in which that can lie. If you got, say, housing prices and they're segregated into the super rich, so it's in the millions of dollars, and then the super poor, and then there's only a couple of houses in between in the middle class, that's not much of an average. It's not much of a middle because the things are so wide apart. So what expected value gives you is a real balanced estimate of average price. It says, look at the prices of each of these things times the, not just the utility, those are the prices, but the percentages of each. And then when you factor that in, remember, expected value was a weighting of pros and cons. In this case, it's a weighting of not just prices, but the percentages associated with each price. So it turns out that even though in your first case, the average is $2 million, which is skewed by the overpricing of certain houses, right? Think of Kaka'ako these days and how much those places cost and how local people are priced out. It's mostly for international rich investors who don't live here. And then the median price, 700,000, may be an underestimate. Maybe you're talking about housing, maybe an overestimate, depending on what you're talking about. So that looks more reasonable. But it turns out that a better notion of average is when you factor in not just the probabilities, but also, or percentages in this case, also the pricing, giving you a more reasoned sense of if these are the average types of prices in the house, and these are the average numbers for each type, here's the real average of the averages. It's going to be 740,000. That's almost never talked about in media because it's too basically sophisticated and complicated a notion, but really it's the only true measure of average insofar as we have one. Okay, so you fill this in. This is just basically from way back when, the notion of combinations and remember permutations. I filled this in, and the reason is we're doing this is to get to the notion of normal approximation. It's basically how bell curves occur. They do this, so if you read this through and it didn't quite make sense, here are the answers. I'm not going to go through it in detail, okay? And then, for each of these, when you calculate using this same pattern here, when you get to 10 out of 32, the 0 and the 5 end up being the same. It's 1 out of 32. The 1 and the 2 end up being, or 2 is in the middle, 10 out of 32. That's what you got here. The 1 and the 4 end up being the same. That's 5 out of 32. So when you distribute it, it's low on each end, 1 out of 32 for 0 and 1 out of 32 on the other end. It's high in the middle, 10 out of 32, so you get something like a bell-ish curve. Okay. Now, it says for the last one, find a number x such that there's only a 1% chance that you find more than 500 plus x or fewer than. What are they talking about here? Basically, what you're talking about is things that are outside of the bell curve. Okay, so if you're talking about a 1% chance that you find more than, this 1% chance is basically talking about the 3 sigma level, and it's outside of that. Remember the 3 facts? 1 sigma corresponds with 68%, 2 sigma corresponds with 95%, 3 sigma corresponds with 99%. So if they say there's only a 1% chance that you find something outside of that range, you're saying there's only a 1% chance that it's outside of the 3 sigma range, which is 99%, right? So to calculate that, and I'm not going to give you the exact formula, I want to see if you can do this on your own. Recall the theoretical definition, or the definition for the theoretical standard deviation. We've already calculated the mean. The mean is, ideal mean is 500, right? And you want to calculate that x. That x is basically, in this case, the 3 sigma range. So 1 sigma, well, sigma is given by, recall, square root of 1 minus p times n. So in this case, you figure that out. So in this case, 3 sigma will be 3 times that. And what you get there, if you calculate correctly, should be roughly 45. That's your x in this case for 3 sigma. For the y, only 5%, that corresponds to the 2 sigma, so you can do that, and if you do it correctly, it should be roughly 30. And lastly, what the graphical information is saying is that there's only, basically, when you plot, when you graph this in terms of a bell curve, what you're saying is, for the first one, there's only a 1% chance that you're going to get more than 500 plus 45, 545. And then for the second one, the 2 sigma, there's only a 5% chance, which is the 2 sigma corresponds to 95, 2% chance that you're going to get something that's 500 plus or minus 30. So 530, or on the other side, 470. All right, if that makes some conceptual sense, great. If not, don't worry too much about it. We're going to work more exercises in the future.